Hi, this is Group Heuristic Bob. In this video, we will explain the work we did in the Pacman Contest project. In the project, we implemented heuristic search algorithm and Monte Carlo tree search to keep the agent decision-making power. We apply the Monte Carlo tree search firstly. This technique can be divided into 4 parts. The first step is selection. We start from root R and select successive child nodes by applying action until a leaf node L is reached. Action selection is according to UCT. The second step is expansion. If this leaf node L has been visited before, then expand this node to add its child as a new state to do the following simulation. Otherwise, do simulation from this leaf node L. We combine these 2 steps into the selection function. The third step is simulation. From the expanded node, perform a complete random simulation within time limit or computational budget. The last step is backpropagate. The value of the node is backpropagated to the root node, updating the value of each ancestor node on the way. After finished constructing the Monte Carlo tree, we make the decision according to the value of QSA to choose an action which may attain more benefits in the future. In addition, we set a timer here to avoid timeout. However, we found that the Monte Carlo tree search has 2 limitations under the game rules. The first point is the limitation of learning time. The game rules stipulate that the decision time of each step of the agent cannot exceed 1 second, and the performance of the learning method is proportional to the number of learning times. We found that Monte Carlo tree search is hard to ensure that the agent can make the right choice every time within 1 second. For example, the difference in decision given by the agent within a few steps is likely to cause the character to move around in a small area. The second issue is how to give a reasonable reward. Factors affecting the agent's decision-making include position of beans, enemies, capsules, home, and the number of beans carried on the body, which makes it difficult to set reasonable rewards when using learning method. The setting of rewards is not only about positive and negative, but more importantly, it is to handle the relationship between the factors and assign their own weights, so that the agent can make the right decision. This is a very big and necessary question.
Therefore, we choose a heuristic method that is more straightforward and has a shorter decision time. We apply the A-star search algorithm in the seek target function to find the shortest path from the current state to goal state. This is our code. And we set different goals in different situations to help the Pacman agent to make the correct move. Our heuristic strategy is to give up defense. First, in the 50 seconds before the start, we will identify all dead ends in the map. A dead end means a way that the weight of it is 1 and there is only one direction back to home. Second, at the beginning, the 2 characters are in the goal state and they will go to the upper and lower edge of the home and enter the other parties of home. We will keep updating a food list. Pacman will eat the beans inside the food list according to the A-star algorithm. If the Pacman detects a certain maze distance with the enemy, we will calculate the beans that can be safely eaten inside the dead end. For example, if the Pacman detects an enemy and find that the maze distance with the enemy is 8, then the beans at the point where the depth of the dead end is 4 or more cannot be eaten, because it will take at least 8 steps to eat the beans and get back. Then the enemy will catch up with the Pacman. We will delete all the unsafe beans in the food list. When the maze distance between the Pacman and the enemy is less than 3, if there is a capsule in the map, the Pacman will choose to eat the capsule. If not, the Pacman will go back to home, then turn into the initial offensive strategy. There are some challenges. Since it is not a learning method, we spend a lot of time on design process. In order to let our A-star search method find the correct path to go under different circumstances. The benefits of this strategy. The approach of the upper and lower roads during the initial attack can avoid being stuck by a defensive enemy. In the offensive strategy, the decision based on the enemy distance and the depth of the dead end can safely eaten beans while encountering the enemy, which can improve efficiency. Using heuristic search algorithms, it is quite hard for enemies to catch our Pacman. The pitfalls of this strategy: we give up the defense, and if the offense is blocked, it is easy to lose the game. We need to handle complex logic to make the Pacman agent to perform correctly. There are some possible improvements. Because our heuristic strategy is to give up defense, so the divisions of label between the two offensive characters Pacman will be a big improvement. It means that try not to choose the same bean target, because it will reduce the efficiency of Pacman. The strategy did a very good job in the map which has capsules, but if there is no capsule in some specific maps, there is a large possibility to lose. So the improvement is changing the offensive and defensive strategy according to the map. For example, the map is without capsules. The strategy of one attack and one guard may be better. If the map has capsules, then the both offensive strategies are more appropriate. Thank you for listening.